What's our world going to look like in, say, 50 or 100 years? This isn't science fiction we're talking about. It's about the future that we are actively building right now. Today, we're going to take a really detailed journey through time, exploring the scientifically grounded scenarios for our planet's climate. We'll look at the best, the neutral, and the worst-case futures across 5 really critical checkpoints: the near-term realities of 2031 and 2036, that crucial halfway point of 2051, the great divergence of 2076, and the long-term legacy that will lock in by the year 2126.
Welcome, everyone, to Bodhi Unified Flow. I'm your host, Dr. Maramuthu. Our goal here is always to simplify complexity and amplify performance. And I'm so glad you're joining me today as we unpack this incredibly important topic. So let's get started on our journey into the future.
So, here's our roadmap. We'll begin with a look at the actual blueprint scientists use to map out our future. Then, we're going to face a tough reality check about crossing that 1.5 degrees Celsius mark. From there, we'll see how our paths can split dramatically, creating a tale of 3 very different futures. We'll also explore the long shadow these choices cast well beyond this century. And finally, we'll bring it all back home to the path we need to choose today.
By the time we're done here, you'll have a solid grasp of the core scientific scenarios that are driving all the climate discussions. You'll understand the critical timeline we're up against, and you'll be able to really visualize just how different our world could become, not just for our grandchildren, but for generations and generations to come.
All right, so how on earth do scientists chart a course into the future? Well, it's not a crystal ball. Instead, they use a set of really meticulously crafted blueprints. These are all based on the potential socioeconomic choices we can make. And these blueprints, they're going to be our guide for this entire journey.
They're called Shared Socioeconomic Pathways, or SSPs for short. Now, the most crucial thing to remember here, the one point to really hold on to, is that these are not predictions. Think of them as plausible stories, or, well, blueprints of what the future could look like. Each one explores a different path humanity might take, based on the big decisions we make about everything from our energy sources to how well we cooperate on a global scale.
Here they are, the 5 core scenarios from the IPCC. You can think of them as the main characters in our story. At one end, you've got SSP 1.19, our best case. The story here is all about sustainability, taking the green road with global cooperation and a super fast shift to clean energy. Then, at the complete other end of the spectrum, you have SSP 5.85, which is a world of rapid, totally unchecked, fossil fuel-driven development. In between, you have scenarios like middle of the road, where things kind of just keep going as they are, and regional rivalry, which is a fragmented world where every nation just looks out for itself. For our journey today, we're going to focus on 3 key paths that really cover the possibilities: the ambitious best case, the middle-of-the-road neutral path, and that high-emissions worst case.
Okay, before we start peering way out into the future, we really have to ground ourselves in what's happening right now and the immediate changes that are already well baked into the system. This is our reality check.
So, as of 2020, our planet has already warmed by 1.1 degrees Celsius above what it was before the Industrial Revolution. This is our starting line. It's not some future possibility. It is a historical fact, and it's the direct result of over a century of human activity. So every single scenario we're about to look at builds from this already changed world.
Now here's what's so fascinating about this slide. It shows us the year 2031, just a few years away. And look at how similar those numbers are. It doesn't matter if we follow the best path, the neutral path, or the worst-case path. The science is telling us loud and clear we are almost certainly going to cross that 1.5-degree warming threshold within the next decade. Why? It's because the climate system has this huge amount of inertia. All the emissions we've already put up there have locked in a certain amount of warming. In the very near term, our different paths just haven't had enough time to split apart yet.
By around 2036, this momentum leads to a really critical shift. The signal of climate change is going to rise above the noise of normal weather patterns. So, what does that mean in the real world? It means the kind of extreme heat waves and floods that used to be called once-in-a-century events, well, they're going to become a much more common, predictable part of our lives. The very definition of normal weather will have fundamentally changed.
So while the next decade is pretty much set in stone, the story changes, and it changes dramatically as we move further into the century. This is where we hit a great divergence, a massive fork in the road where the choices we make today start to create profoundly different worlds. But even before we hit that peak divergence in 2076, let's stop at a midway point, 2051. By then, the paths are already separating.
In the best case, emissions are dropping fast. In the worst case, they're still climbing, and we're starting to see the early signs of irreversible changes. The 2050s, that's the decade where the consequences become truly undeniable.
And that split just keeps getting wider until the Intergovernmental Panel on Climate Change, the IPCC, itself points to the year 2076 as the moment of maximum divergence. This is it. This is the point in time where the difference between following the best path versus the worst path becomes just unmistakably, starkly obvious. This is the year when the two planets we could be living on are the most different from each other.
And this table, wow, it just lays it all out. Look at the temperature. In our best-case world, warming has actually leveled off and dipped slightly to around 1.4 degrees. But in the worst case, we're soaring past a catastrophic 3.5 degrees. And the Arctic, in one future, that summer sea ice is still there. It's hanging on. In the other two, it's pretty much gone, or entirely gone. And that ocean pH, which measures acidity, a drop to 7.75, I mean, that's a chemical change so profound it actually threatens the very foundation of the marine food web by dissolving the shells of creatures like corals and plankton.
Let's just paint a clearer picture of these two worlds. Okay, in 2076, on that best-case path, the planet is stabilizing. We've managed to pull back from the brink. The actions we took back in the 2030s and 40s have paid off, and delicate ecosystems like coral reefs might actually have a fighting chance to recover. But in that worst-case world, we're facing runaway warming. We risk crossing irreversible tipping points, like the Amazon rainforest flipping from being a vital carbon sink into a carbon source, which would just accelerate the whole crisis. You see, these aren't just slightly different scenarios, they are two fundamentally different planets.
But the story doesn't just stop in 2076, or even at the end of the century in 2100. Some of the biggest, most consequential changes, especially in our oceans and our massive ice sheets, they take a much, much longer time to play out. The choices of our century are going to cast a very long shadow.
This is because of something called climate commitment and thermal inertia. Here's an analogy. Think of our oceans and ice sheets like a massive freight train. Even if you cut the engine today, its sheer momentum will carry it forward for a very, very long time. The heat we've already added to the ocean and the melting processes we've kicked off in the ice sheets, they are committed to continue for centuries, no matter what we do with our future emissions.
By the year 2126, these long-term processes start to get locked in. We're talking about self-sustaining feedback loops. For instance, as the permafrost thaws, it releases massive amounts of greenhouse gases. This causes more warming, which in turn thaws more permafrost. It's a vicious cycle. The same thing happens when the bright reflective Arctic ice disappears, leaving behind a dark ocean that absorbs more heat. These aren't just consequences anymore. They become engines of their own change, a legacy we're passing down for thousands of years.
And nothing illustrates this long-term commitment better than sea level rise. Just look at the difference by 2126. Even in the absolute best case, we are locked in to about half a meter of rise. But in the worst case, it's over 1.3 meters, and it's still climbing fast. What does that actually mean? Well, half a meter displaces millions of people in coastal communities. 1.3 meters? That threatens the very existence of major cities all around the world. That staggering difference is the direct, irreversible legacy of the path we choose in this century.
So, after this whole journey through time, from the tough realities of the near term to these long-term legacies, the question has to be, where do we go from here? What is our path?
Let's do a quick recap. We've seen that crossing that 1.5-degree line is pretty much locked in for the next decade. We've seen that the period from 2051 to 2076 is this huge fork in the road that leads to two completely different planets. And we've learned how the choices we make right now commit future generations to centuries of change. But the most important takeaway, the one I really want you to leave with, is this. The worst-case scenario is not our destiny.
As the IPCC report itself concludes, the story is not yet written. The entire trajectory, from that great divergence in the 2050s all the way to the legacy in 2126 and beyond, is being determined by the decisions we are making right now, in this decade. We are the ones holding the pen.
So the final question really is for all of us. The blueprints for the future are laid out right in front of us. They show paths to vastly different worlds, with profoundly different consequences for every single living thing on this planet. Which one are we choosing to build?
All the data and the scenarios that we've explored today are drawn from the incredible, comprehensive work of the Intergovernmental Panel on Climate Change and from NASA's climate modeling teams. Thank you for joining me on Bodhi Unified Flow. I'm Dr. Maramuthu.